Hello, for my properties of matter reassessment, I chose to do a similar problem to the assessment with different numbers, and I wanted the length of the wire to be 1.8 meters, the radius of the wire to be 0.006 meters, and a 15 kilogram mass to be hung from the wire to stretch a distance of 5.5 times 10 to the negative 3 meters. I first wanted to determine the spring stiffness as if it were a microscopic spring. So I know that the magnitude of the force is equal to the K, the spring constant, times the stretch. And I also know that it is equal to the mass times the acceleration. So I know the mass and the acceleration, and also know the stretch, so I can get Ks, which is 26,727 newtons per meter. Then I next wanted to find the Young's modulus, and I know that Young's modulus equals to the force over the area divided by the delta L over the L. I put it into just one fraction, the force times the length over the area times the change in length. The area is for the area of a circle, which is pi r squared. Therefore, Young's modulus is equal to the mass times the acceleration times the length divided by pi r squared delta L. So 15 kilograms times 9.8 meters per second squared times 1.8 meters divided by pi times 0.0006 meters squared times 5.5 times 10 to the negative 3 meters, and that is equal to 4.3 times 10 to the 10 Newton per meter squared. And then next, I wanted to determine the spring constant as if it were a interatomic bond. So a single interatomic bond. And to do that, I have the Young's modulus, which is equal to the interatomic spring constant divided by the diameter of the spring, the circular spring. So that's the distance apart that the interatomic bonds are. So multiply Young's modulus times the distance, and that will give me the interatomic spring constant, which is 17 newtons per meter.